So depending on like who your geometry teacher was, sometimes they teach this, sometimes they don't. The law of sines isn't particularly hard, but it has to do with like kind of like trig ratios, and it's going to deal with solving a triangle as well. So that's kind of what we did before break. We solved some triangles. We did not use the law of sines though. So prior to Christmas break, we did solve for like the missing side of a triangle. You don't need to write this down, but what do we use to find the missing side of a right triangle? Yeah. Yep. Diagram theorem. Or the a squared plus b squared equals c squared, right? That's how we solve for the missing side of a triangle. But notice this says we solve for the missing side of a right triangle. Pythagorean theorem you cannot use for a triangle that's not a right triangle. So it can only be used for right triangles. In math, that's often the case that we want to solve a triangle that's not necessarily a right triangle. A right triangle has to have a 90-degree angle. Sometimes we want to solve a triangle that doesn't have that. Or maybe we only know one side of the triangle. Pythagorean theorem, we need to know two sides in order to do Pythagorean theorem, right? So often the case we only know one side, and so this isn't going to work, which means we need something else to try to solve it. And here comes the law of sines. That's going to fulfill this problem that we have. All right. So the law of sines is not complicated. Pretty easy formula. But we're going to set it up here first. So the law of sines we use for any triangle. We're going to call the sides little a, little b, and little c. They don't necessarily have to be a, b, and c. They could be like j, k, and l or something like that. Or l, m, and n, something like that. But the main thing is we're going to call the sides the little letters. And then the opposite angles we're going to call the big letters. Okay. And then we'll draw a picture of what this looks like. But sides are little letters, angles are big letters. It's just in math how we do this. And it would have been the way that you would have done it in geometry if you've seen this before. So let's draw a triangle. I just draw the same picture, literally for any scenario given. Let's draw a triangle that looks something like this. And we'll just call the corners A, B, and C. Triangle ABC. It is important how you label this, though. It doesn't matter what letters you use, but it's important where you put these letters. So opposite of big A is the side little a. So that's going to go over here. It's opposite of the big A. And opposite of the big B is little b. And then opposite of the big C is little c. It's important that you get these in the right spot, or else you'll get the problems wrong because you'll label the whole thing incorrectly. But you're basically just going to draw this triangle for all of our problems. Right? So this is our setup, and then the law of sines looks like this. The sine of big A over little a equals the sine of big B over little b, which equals the sine of big C over little c. So that is the law of sines. Basically, the sine of any of the angles over the side opposite is equal to any of the other sines of the big angles over the side opposite. Have you seen this before? This slogan that has. I think you'll find these are not terribly difficult. Okay, so where do we use this? We're going to talk about where we use it first, and then we'll actually use it. So we're going to be solving triangles. Solving triangles. To solve a triangle, that basically means that we're going to find all of the angles and all of the sides. If we have something solved, to solve it, so we find all of the sides and the angles. And there's a couple different scenarios we could use this law of sines for. Today we're just going to look at the first scenario. So we'll just call this case 1. And you might be familiar with these abbreviations here as well. Probably bring back some geometry memories, hopefully not bad memories. So the case 1 where we're going to use this law of sines, and this is what we're going to focus on today, is if we're given one side and two angles. One side and two angles. So we definitely could not use Pythagorean theorem because we only have one side, so no way to use that. Let's draw these two scenarios. So for example, maybe we're given something like this. We're given A, here we got A, B, and C. So maybe we're given that big A is 30 degrees, and then we're given this side over here, let's say it's 10, and then we're given the C over here, maybe it's 25 degrees. Okay. So that would be an angle, a side, and an angle. Remember that, like this different postulates from geometry. We won't use them much, but this is a scenario where we could use the law of sines. We've got two angles in the side between them. Okay, and then the other scenario, the side angle. So maybe we're given this side up here is 5. This side's 5, and then we've got two consecutive angles that go with it. So maybe this angle here is 50, and this one is 30. Okay. So we got a side and angle. Basically any combination of one side and two angles. So if we get a scenario like this, that's a good time to use the law of sines. There's just another one, but we'll talk about that tomorrow. Okay, let's try to solve one. So our first example here, we're going to solve this triangle. We're given A is 40 degrees, B is 20 degrees, and little a is 2. Just notice that these are all in degrees. So for this next couple sections, we are going to be talking about degrees rather than radians. So what we're going to do in all of these is we're going to start by just drawing a picture. And just draw the same picture every time. Makes it easy if you don't have to change it. Just draw the same sort of triangle. It doesn't matter what the angles actually look like. And we'll call this ABC. Go. And then let's even go ahead and label all of the opposite sides. So opposite of big A is little a, opposite of big B is little b, and opposite of big C is little c. And then we'll go ahead and write in the information that we know. So big A is 40, big B is 20, and little a is 2. We have two angles on one side. That means we can use the law of sines. I'm going to go ahead and write it out here. Sine of big A over little a equals the sine of big B over little b. And you can change the order on all these. You can also say that just sine of big A over little a equals sine of big C over little c. They're all equal to each other. Basically, it says you can just write them in any order. They're all equal. All right, so what we're going to do is choose one of these. Then we know both of them. We're looking for like a pair where we know both of the variables. So which pair do we know? All right, we know A. So we're going to choose A to start with. And instead of writing the sine of A, we're going to write the sine of 40. A is 40. So sine of 40 degrees over little a, which is 2. And now the next easiest variable to solve for, because we've got to solve this whole triangle, we need to get this, we need to get this, and this, would be little b, because we know what big B is already. So we're going to set this equal to the sine of big B, which is 20, over little b. So we use that ratio. And then we're going to try to solve this. Any ideas how we can solve this? Yeah? Oh, okay. So yeah, we will do that in just a minute, but finish solving this one first. Okay, times both by 2. Okay. So we still have that B over there. I think I know what you're doing. I think what else? How can we get rid of the B then as well? Essentially, times by B, right? So what ends up happening if we do this times 2 and this times 2, right? And then this times B and this times B, is it ends up just being cross multiplying. If you just do this times this, so sine of 40 times B, or sine of 40B, and then multiply this as well, so equal to this multiplied, equals 2 times the sine of 20, which is 2 sine of 20. So we're going to cross multiply. You might remember back in the day, if you had something like 2 over 3 equals x over 5 or something like that, where you cross multiply and solve. This over there. Okay, and then we want to get the b by itself. So then we're going to just divide by all this that's attached to the b. So we'll divide by the sine of 40 degrees. That cancels. And then we're just going to be typing this whole thing into our calculator. So you will need a calculator for this section. If you want to go ahead and grab one now, if you don't have one, that's fine. Grab one. And before we actually solve it, I had my second period class to do this, but I want you guys to check too on your calculator. Is we're in degrees, so we're going to want to make sure that our calculators are in degrees, because the last chapter that we did, we were in radians. This is going to be in degrees. So how you check that is you're going to hit mode. Mode is right here next to seconds. And the third line down there, it says radian in degrees. It should be highlighted on degree. You want to make sure it's on degree. If it's on radian, you want to go down and then move it over to degree and hit enter. And then you can just hit seconds and then mode again, which will be quick. So just make sure that your calculator is on degrees. And then so we're just going to type all of this in our calculator. The way to be most careful would be, since this is a fraction, would be to type it in parentheses. It shouldn't work fine without parentheses. But if you do a parenthesis 2 sine, and then it will automatically give you a parenthesis. 2 sine of 20, close parenthesis, and then divided by. And then you could put the denominator in parentheses or not, doesn't matter. Parenthesis, sine, and then it will automatically do parenthesis 40, close parenthesis 40. Just type it in like that, and see if you can get the correct answer. Make sure you close all your parentheses well. And you should get 1.06. So you can check and make sure you're doing it right. So we got B. Now we need to get two more things because we're solving it. We need to get big C and little c. And so, Naya, how do we get big C? Very good, yeah. Because we know two of them, to get the third angle, we're just going to use the fact that all of them should have to equal 180. So we just do 180 minus 40 minus 20. Or just 180 minus 60. That's 120 degrees. So you don't have to use the law of sines for that part. The third angle there. And the last thing we need now is little c. To get little c, we're going to use the law of sines again. And just like we use sine of big A over little a for this, we're just going to do that same thing again. Except instead of setting equal to the b, this time we're going to set equal to the c. I always just stick with the same ratio you used to begin with. So we'll do sine of 40 over 2 equals, and now instead of solving for b, we're doing c, so it's going to be the sine of 120 over little c. So the same ratio we used before is that same fraction, this time something over there. And then we're going to solve it the same way. We're going to cross multiply and divide. So these get multiplied. Sine of 40 times c equals 2 sine of 120. And then just divide. That's sine of 40 on both sides. And everybody got that one? Point. No figures. 2.69. Now, before we move on to the next problem, I want to show you one thing that we're going to do to check. So how can we be sure, or at least pretty certain, that these are the correct answers? Well, you'll remember something from geometry which said that the bigger sides are always opposite the bigger angles. You remember that fact? So in other words, if you have a big angle, let's say angle looks like this, right, and these are really small angles, this side is going to be the longest side, right? Because this has the biggest angle. So the same is true for the smallest one. The smallest angle will have the smallest side opposite. So what I like to do to check is find the smallest angle, that's 20 degrees here. Does it have the smallest side opposite of it? It does. It's 1.06. So these are the smallest, right? And the biggest angle, 120, does it have the biggest side opposite of it? 2.69, yeah, that's the biggest side. So a good thing to check is, at the end, make sure the smallest angle has the smallest side opposite, and the biggest angle has the biggest side opposite. Obviously, my drawing isn't correct. It doesn't really matter that it's correct. This definitely is not 120 degrees. That doesn't really matter. It's just you want to make sure this angle and this side are opposite, because they're the biggest and the smallest ones are a pair as well. And then obviously the middle one would be the middle. So a good little way to check there. All right, I want to do this one, at least one more here, maybe two. We go a little faster after you get the hang of it. So this one we're given A, and we're given a couple C's there. You should always draw the picture, even if you think you know what you're doing without it. It's a good idea to go ahead and draw it. Just draw A, B, C. And if you just draw the same picture every time, it makes it easy. little a, little b, little c. All right, and then for A, we're going to label that 110. With C is 30. And we'll see this. And the first thing we're always going to do is look for the pair that we have. In this case, we don't have both the A's, so we're not going to start with that. But we do have both the C's, so we're going to start with that fact. We do the sine of the big C, which is 30 degrees, over the little c. Start with that. We've got to get everything. The easiest one to get next would be little a, because we know what big A is. So then we'll do the sine of 110 degrees over little a. And it's just going to be our cross multiplying and dividing. The process is really similar every time. Boom, boom. Multiply this here. So this is sine of 30a equals 3 sine of 110. And then we're going to divide both sides by sine of 30. Just type it in. Anybody get an answer for that one? What do we get? That's what 6 0.63 or 0.64 years. 5.64. Okay. And then you can even check at this point. If the first one was 30 and the side opposite was 3, this one's 110 and the side opposite is 5.64. So it makes sense so far. Bigger side opposite, bigger angle. All right, now we got to get big B and little b. So I want to get big B next because we know it's these two angles. So then for big B, it's going to be 180 minus these two, right? Minus 110 minus 30. So minus 140. 40. Big B. And then so we just do the rule one more time. Sine of, you can always just do whatever I use for that. First, sine of 30 over 3. It's easier than using the new one we found because the new one with the A's would have a decimal, and the decimal's rounded, so I'd rather not use that. Sine of 30 over 3 equals sine of big B, which is 40, over little b. And you can even, after you do this a couple times, maybe just skip the middle step. These two get multiplied and then you divide by that one. So it ends up just being b equals 3 sine 40 divided by this one, sine 30. So you start to get the hang of it. Just skip that one step. Then we need to make sure you draw a picture for each one. And then we're just going to type that in. Anybody get an answer for that one?
3.6.
Good. Let's double check that all of them make sense. So our biggest angle is 110. It is opposite our biggest side. Our smallest angle is 30, and it is opposite our small side. Okay. So it should be all good. Guessing you got a handle of it now to do it. So we won't do a whole nother one, but I just want to show you, so I have to write this down. This one is an example of just going to draw it really quick. A B C, 40 degrees, 40 degrees, and then C is 2. So we're not actually given a pair on this one, right? We're not given like a B, big B and little b, or a big A and little a. So what would be the first thing you have to do on this one? Yeah. Yeah, you want to figure out big C first. You're just going to change the order up a little bit. So this is 40 and 40 is 80, right? So this is going to be 100. And now you have a pair, and then you would use big C's, big C and little c. So sine of 100 over 2, and then you could solve for little a or little b at that point. So if you're not given a pair, you're just going to have to solve for the third angle first, and then you'll have a pair. Make sense? Cool. All right, so I'll give you some time here. You'll have like 15 minutes or so to work on your assignment, if we can get done or most of it done. Which is it's just 4 problems. You have to solve the whole triangle, so make sure you draw the triangle. And I haven't put the picture up quite yet. I'll put it up here in just a minute. You have to draw triangle draw. Make sure you draw those. And upload that here. Just a sec. If you don't have your book,